What's up? What's up? What's up? It's your boy, the network. Today's topic is section 3.25, configure and verify OSPF neighbor relationship and authentication. This is part 2 of this section. We did configure and verify neighbor relationships. Today we're just going to focus on authentication. This is a topic in the CCNP route exam, the older version. 300-101 version 2.0. Remember the new one? I'm going to keep repeating this until not to the day I die, but until it comes out, February 23rd, 2020. That's when the new CCNP enterprise exam come out. Let's take a look at the exam blueprint and see where we came from, where we're headed. This is the exam blueprint, implementing CISCO IP routing. Again, this is the new version, 300-101. I've been, looking at the new tracks and stuff like that. They really shook up the networking and route and switch world, even security and stuff like that. They got rid of the CCNA. They got rid of a whole bunch of associate level tracks. Now it's just one CCNA. They got rid of security, wireless, until you get to the NP level, then you could specialize or whatever. Anyways, we just finished up the neighbor relationship portion. We are going to do authentication today. After that, we are going to move on to configuring and verifying the network types. Well, we know what authentication is, right? Authentication is, simply put, username and password. There's other ways you can, do retinal scan and facial recognition, that kind of authentication and stuff like that. But when it comes to OSPF and neighbor relationships and stuff like that, we use passwords and hashing and stuff like that to authenticate with our neighbor. Remember, we said to become an OSPF neighbor, there's several parameters that has to match. Well, authentication can be one of them if it is set up. So you know what authentication is when we are setting it up for OSPF. It's basically a password. So let's say it's kind of like authentication on an email account, right? The email account is pretty much set up in the cloud somewhere. Really it's stored on an email server. That's publicly available to you, right? But being that it's on the internet, it's really on a DMZ, but it's on the internet. Since your email account is on the internet, pretty much anybody can get onto it, right? Well, since we set up authentication on your account, Gmail, Yahoo, whatever email account you have, you got to put in a username and password. So not everybody can go into your email account all willy-nilly. That's the point of authentication. So take this same concept with OSPF, and that's what we're doing here. Let's take a look at these slides real quick and break down OSPF authentication. So the purpose is to encrypt and authenticate routing information, right? So being that let's say you got some routers in your network, they're OSPF, right? If anybody can get onto your network, if they can just, get your OSPF routes, they can pretty much change your network topology and just pretty much hack your network, really. So that's where authentication will come in to kind of, mitigate that, or at least safeguard your OSPF routes. This is an interface specific configuration. So when you're setting up authentication, you're doing it on the interface, not just on a router as a whole. You do it on specific interfaces. So like, for example, this is router 2 right here. You're setting up authentication here. And if necessary, this is a local area network. You can set up authentication there as well. Routers will only accept routing information from other routers that have been configured with the same password or authentication information. Then that's what we're going to do on Boson Netsim. I've been using Boson Netsim a lot. I realize I really do like it. We ain't strayed away from GNS3. I know we got a couple more labs that we only halfway through the blueprint, and we are going to do some GNS3 labs. Maybe we might bring up packet tracer again later on. So when it comes to neighbor authentication, there are 3 types: type 0, type 1, type 2. In short, type 0 means no authentication. Type 1 means clear text, which means type 1 is clear text, which means you can see the password written out. And type 2 is MD5 authentication, which is hashing. Not the same thing as encryption. It's hashing. It's basically jumbling up your password, and you can't really see it. Well, not really jumbling up your password. It's kind of like jumbling up the password, and you can't really see it. So that's what hashing is. To configure authentication, you must enable it for either the area or interface. You then need to configure an authentication key, which must be done per interface, which we just mentioned. And OSPF does not support the use of a keychain like EIGRP, but multiple keys can be configured per interface. These are the configuration commands. Let's go race through this because you're going to see it in Boson Netsim anyway. You go to router config mode and just do That's weird. No, when you go in the router, you can go in the router config mode and do it by area, authentication by message digest, or you can do it per interface, this is how we're going to do it in Boson Netsim. For type 0, you got IP OSPF authentication. No, I don't know why you would do it this way, because you're pretty much not setting a password. I don't even know why you would even use that. Type 1 is clear text. You do IP OSPF authentication. Of course, you got to go in the interface. Go there. And type 2, which hashes the password, you go to the interface config mode, IP OSPF authentication, message digest. And the second step of the process, you must configure an authentication key per interface. I believe we did. Is that the same thing? No. Oh, that's like the name of the key when you type in the actual password. So you do this or this, and then you do this or this. So you add the password to each one of these, depending on whether you want clear text or hash password. These are the verification commands. I forgot about this one right here. It took me a minute to remember this one right here. Show IP OSPF interface. You could also do debugging and debug IP OSPF adjacent. I believe that's adjacent. Anyways, let's go ahead and launch the Boson Netsim and do some authentication. Okay, here we go. Standalone lab, OSPF authentication. The objective here is obviously understand OSPF authentication. This is the lab topology. Without going through everything real quick, we got, as you can see, Orlando, Tampa, Miami, Key West, and Daytona. Pop quiz. What state is this in? I'm actually in here on Orlando. Hey, check that out. Representing the Magic, Orlando Magic. Even though Toronto won last night for the NBA Finals, congrats to them. Kawhi Leonard is a beast. Anyways, so yeah, we've got the wide area network. We got these cities sitting in the wide area network. Then we got Key West sitting out here, and the local. Each one of these routers have a local area network, a host in each local area network, respectively. Let's go ahead and move on. We got some basic commands here. We mentioned the show commands. This is the IP addressing guide. These are the hosts. I think I'm gonna skip this task right here to examine initial configuration. Basically, they want us to. Let's just do this part, but we're not going to verify connectivity. I'll tell you right now, every host can ping each other, and every router can ping each other. So we're just going to skip that part right there. You just do ping and an IP address. I'm pretty sure you know how to do that. So on Key West, examine the routing table. Let's go to Key West, which is located right here. How do you examine the routing table? Let's put in the password first. CISCO, enable, and then do CISCO again. Show IP routes. That's the routing table. We got 4 OSPF routes. And 4 more OSPF routes here. So total of 8 OSPF routes from Key West. He has 8 OSPF routes here, right? Verify connectivity. I'm not going to do all of this. That's just not really a waste of time. I just know that it worked because I did it before. So from host B, same thing here. So from host B, we're going to ping Key West's FA00 interface, which is located, I believe, on the local area network. Let's see. FA00 is located on the local area network. So we're going to have this guy ping the IP address that's located on there, and it works. So is this ping successful? I'll do it just for shits and giggles. Let's just do that part at least. Ping 200.120.45 and 193. 45.193, right? 45.193? Yeah. Is this ping successful? Yes, it is, just in case y'all don't believe me. All right, so we did all that. That's task 1. Task 2, understand OSPF authentication. Let's first of all understand unauthenticated OSPF authentication. Unauthenticated OSPF, so basically no password. Full connectivity is established when you load this lab. As you mentioned, OSPF is properly configured and routes are being advertised. Briefly explain the requirements that allow routers using OSPF to exchange routing table updates. Well, we mentioned that in the last video. The IP address have to sit in the same subnet. The hello timers must match. The dead timers must match. If authentication is set up, the passwords must match. There's also something else. MTUs must match. There's several other criteria, but those are the main ones. What security risks related to OSPF exist when network is configured in this manner? Well, the security risk, if you don't set up a password, anybody can jump onto your network. If they have an authorized router connected to your network and join and become an OSPF neighbor, they can pretty much change your whole topology network. They can just trash the place, basically.
Too much money on this game. Man. Fuck you, Curry. Bitch. Fuck. Fuck.
Hey, hold up.
Fuck. Fuck, I lost too much money on that shit. You fucking bitch. Fuck now,
Whoa.
That's a security risk. Understand authenticated OSPF. Briefly explain how implementing OSPF authentication might mitigate the security risk that you previously outlined. Well, it's just like this. It's just like you having an email account, right? With no username and password. Obviously, you're making it more secure by adding a username and password. Same concept lies with OSPF authentication. Task 3, implement basic authentication. This is what we came to do. Hands-on. Configure the authentication credentials. In this lab, you will begin by configuring OSPF authentication between Key West and Miami. Where's those guys at? Key West, Miami. So we're going to configure authentication here. Which interfaces are used to connect Key West to Miami Key West and Miami to the Key West Miami WAN serial link? Where's the Key West Miami WAN serial link? Key West Miami. Well, basically this right here. Basically what they want to know here is, what is the interface that lays here and the interface that lies here? Well, we have these easy pop-ups that's going to tell us. We could also just look at the description in here by doing show IP OSPF. We'll just make it easy so we can look at the pop-up here. What connects us to Key West? FA01. But if you wanted to know, we could also just do CISCO and go in there, enable, and do show CISCO, and then so much for security, right? Show interface FA0/0. That connects us to the Miami local area network from Miami, right? We're on Miami right now. Yeah. We don't want to do that. That's the Miami local area network. We want to know that guy right there. So I believe that's FA01. So let's do show interface FA0/1. That connects us to Key West. So that's one way to do it. Or you could, like I said, look at this topology. Although in the real world, it's not going to be that easy unless you have some monitoring tools that just lays out your topology like this. So let's see. We said we need to set it up on FA01 and set up authentication, right? Which interfaces? So FA01 and on Key West, we need to find that out. Show, I believe it's the same interface. So let's just do show interface FA0/1. That connects us to Miami, A305, just like we said. So FA01 is what we need to set it up as. On both of them, we need to set up authentication. On Key West and Miami, my bad, right here. On Key West and Miami, enable OSPF authentication on the interfaces you previously identified, right? So let's do Key West, interface. No, we need to go global config mode, interface FA0/1, and then do IP. It's OSPF authentication. That's the first key command you want to click. Let's run some show commands real quick. Just real quick. Show IP OSPF interface and then the interface. All right. So let's see what we set up so far. Show IP OSPF interface. In this case, it's FA0/1 and see what we did. Come on, man. We got to add a do because we're in global config interface config mode. So Control A, show. Notice the dead timer expired because we set up authentication on this one, but we didn't do it on Miami yet. But let's see what we did so far. Do show IP interface, IP OSPF interface FA/01. And you can see right there, simple password authentication is enabled. So let's go to Miami. We know it's not set up because we didn't do that password yet. Plus, we dropped an OSPF neighbor. I guess we could have seen that they were OSPF neighbors. Oh, we already mentioned that they're already OSPF. So we do show IP interface OSPF interface. No, my bad. Show IP OSPF interface FA0/1. And you can see right there. Is that what we said? No, that's not what we wanted. Show IP OS. What was the command that we just did? We did show IP OSPF interface. Yeah, that's what it was. Maybe because it's just not show. Show IP OSPF interface FA0/1. Oh, it doesn't show it there. So I wonder why. Maybe because OSPF dropped. Oh, but it just adds it to you. It just adds it there. So it's enabled there. So we did show IP OSPF interface, and then that didn't, so it didn't work there. So let's go ahead and set it up on Miami anyways. So configure terminal interface, and then we'll run that command. FA0/1 IP OSPF authentication. Helps if I spell correctly. Authentication. Now we set up OSPF authentication, and let's do a show IP OSPF interface FA0/1. And now you can see simple password is enabled. That should bring the neighbor back up, I believe. While it's doing that, let's see what it says here. On Key West in Miami, configure an OSPF authentication key on each interface. Use the text string or password San Jose as the authentication key on both routers. Did we find his neighbor yet? Let's go to Key West. There he is. Loading to full. We talked about those steps in the last video. So now we're OSPF neighbors again. Let's go to Key West and verify that. We can see that right there. Do show IP OSPF neighbor. And you can see right there full, and there's his neighbor. It's Miami. So now we need to put the password San Jose, right? How do we do that? IP OSPF authentication key, and then the name of the key. That's how you do it. We are in the interface FA0/1. Let's just do that just in case. And then do IP OSPF authentication key. We said the password is going to be San Jose. Let's see what happens. We put the password on Key West, but we didn't do it in Miami yet. So let's go on Miami. While it's doing that, let's run a show command. So right now it's full. Our OSPF neighborship is full. Let's see what verification command we can see. Let's do a OSPF. No, we don't want to do OSPF hello. We know it's saying hello every 30 seconds. Let's do IP OSPF adjacency. We're going to go to Key West and do that. Debug IP OSPF ADJ debut. My debut album, debut. I still did it. What am I thinking? Debug, fool. Now, OSPF adjacency events are on. Let's see what's going on here. Are we saying hello? Are we being adjacent? Basically, okay, it went down, I believe, right there. No, that was before. That was from before. Oh, yeah. Let's see if Key West has a neighbor right now. Do show IP OSPF neighbor. No neighbor, because we put the password on Key West, but we didn't do it on Miami. So let's go ahead and go to Miami. Right there, you can see the dead timer did expire. And IP OSPF, put the same command there. Authentication dash key. We said it's San Jose. That should be the password. And let's see what happens on Key West now that we're debugging Now we're debugging. Anything going on yet? Are we neighbors? It's supposed to say, every 10 seconds there it goes right there. BDR election, who is a DR designated router or backup designated router. And basically we're neighbors now. So we go to Miami and you can see there it is loading. So now we're neighbors. Okay, so does the same text string need to be used on each pair of interfaces for authentication to succeed? Yes, that's a given. If we put different passwords on each router, they're not going to become neighbors. Okay, view routing tables. Task 4, view routing tables. Verify routing tables. After you have configured authentication, display the routing table on Key West. Let's go to Key West. Right here. Let's get rid of the debugging because we don't want to do all that all the time. No, and show IP routes. And he says here, compare the current contents of the routing table to routes you previously observed. We didn't previously. Oh, we should have previously observed a route. Oh, we did. We said it was 8 routings. We said it was 8 OSPF routes. We got 4 here, 4 there. So it's still the same. Do you see any changes since implementing the OSPF authentication? No. Briefly explain. No, because there's not no explanation. Verify connectivity. From host E. Host E is right here. Ping the following IP addresses. I'm not going to do that, but they will all work, I believe. Are these pings successful? If not, review and correct your configuration. So basically, we have an OSPF neighborship here, and we want host E to ping all these other hosts, which they will work because we're we established OSPF neighborship there. So it'll all work. I'm not going to sit here and ping every one of these hosts. From host B, ping Key West. We're going to do ping host B, ping Key West's FA00 interface, which is right there. Is this ping successful? Well, let's go ahead and do that. Let's go ahead and do that for now. Ping, that's just one host. I could at least do that. 200-120.45.193. And that worked. No loss. 100% connectivity. If not, review it did work. Based on your behavior you observed in the previous 2 steps, what conclusion can you draw regarding the operation of OSPF authentication between Key West and Miami? Well, we know that the OSPF neighborship works, and now there's authentication. There's password set up on both routers for OSPF neighborship. On Key West and Miami, display additional OSPF about the operation of OSPF. There was one I said we needed to do, and I believe it's show IP. That's not wrong. That's the host. Key West. Let's go ahead and do. That's what I mentioned before, because I didn't really know about that command that well, or didn't really experiment with it. Show IP OSPF interface FA0/1, and you can see right there, simple password authentication is enabled. Another way you can verify that is just doing show IP, I believe OSPF, and you can see, what else can we see here? That's the area has no authentication. That's something else. That's not the same thing as interface. If we did it by area, we could have done it that way. That's basically what we mentioned in the slide earlier. If you don't know what that is, or if you don't remember that, just rewind back. I'm not going to go back and forth between these slides. We're approaching our limit here. Let's do a show IP. Well, we just did that. We could also do show run and see that. So if you do show run, go on the interface and you can see here, or let's just do show run pipe interface FA0/1. Let's just do section interface FA01, and there's the passwords right there set up. Description in Miami, so the authentication. So you show run. When all else fails, show run, but you want to challenge yourself by not doing the show run. Task 5, implement OSPF encrypted authentication. So now we are going to do the same thing, but we're going to encrypt them. That's where MD5 comes in. You have now implemented OSPF basic authentication. Briefly explain the potential security risks associated with OSPF basic authentication. Well, you still can get hacked because the passwords are clear text. That's basically what we're doing. Remember, we got these 2 types. There's type 0, no authentication. That's like basically, that's like going in raw. you bare skinning it right now. You going in, you.
Ooh, baby, I like it raw. Yeah, baby, I like it raw.
No condom, Type 1, you clear text authentication. That's basically you saying the password. You putting a post-it note on your monitor. Type 2 is more secure. It's MD5 authentication. You're hashing or encrypting the password. This is the most secure way. So type 1 is what we just set up. Now we're going to move on to type 2 authentication, MD5. That is the risk you're taking. Unless your pullout game ain't right, but there's no such thing as pullout game when it comes to networking. Review the commands you issued to enable basic authentication between Miami and Key West. We just did that. You now need to remove these commands. So basically, on Key West, we did the show run on Miami, right? No, we did the show run on Key West. So we basically got to remove these 2 commands right here. So let's go ahead and do that on interface FA, go into global config mode, config terminal interface FA0/1, and then interface FA0/1. Come on, man. No IP OSPF authentication. You also want to remove the no IP OSPF authentication. I believe you could just do authenticate. Remove one at a time. I like being thorough. San Jose. That should drop our neighborship there. So we go to Key West. We are in Key West. We'll move on to Miami, as you can see right there. Loading to full. We haven't dropped neighborship just yet. But let's go ahead and do a debug so we can see. You'll see it, but debug IP OSPF adjacency, and you should see them drop in a couple seconds. There it goes right there. So now we're going to do the same thing. Global config mode, interface FA0/1, no IP authentication, and remove the no IP OSPF authentication. My bad. OSPF authentication, no IP OSPF authentication dash key San Jose. Let's do this. We did that, right? So right there is dropping again. Let's do a show run and see what we removed, since we just removed the authentication. We didn't remove password yet. And look, you can see that's our events right there. It's re-electing. It's basically rerunning the OSPF algorithm right there. SPF algorithm, rather. And you still see the password there. So now we need to remove that guy. Dash key OSPF. I'm sorry, San Jose. Now we remove that guy. No, it needs to be no IP OSPF authentication. So we remove that guy. See, and this is why I split it up in 2 videos. This is why I didn't want to set up authentication with the other one and put them up on the same video. So we remove those keys, reconfigure Key West. Let's go to Key West to use message digest authentication. So we're gonna do the same thing, but add the password San Jose, but we're doing MD5. How do we do that? For the interface, we do IP OSPF authentication, message digest, and then you do IP OSPF message digest key MD5, the key number, and then the name of the key. So we are going to go do that. On here, we do IP OSPF authentication, and I'll show y'all the options here. Message digest. So if you want no authentication, it's no, right? That's when you go in raw. I put no. That's not supposed to happen there. We'll get rid of this no. So there we go. Now we've got it. IP OSPF authentication. Message digest. We should debug our events here too. We should. No, let's skip that for now. IP OSPF. What else we need to do? Message digest key. Put in the key ID. No, we didn't want to do that. No, we don't want to do all that. Let's just do IP OSPF, and then is it message digest key? So now we got to see. Now we've just lost a neighbor because we're trying to set it up. Message digest key. I guess we're gonna do key ID 1. I don't remember if that's what you're supposed to do here. And then MD5 for the MD5 algorithm. And then the password San Jose. And then because it don't really say to use key 1, but we're gonna go ahead and do that anyway. Let's go ahead and check the answers. I'm not gonna front for y'all. Task 5, 3. Yeah, it says 1. They didn't even tell us which key to use, but we did it anyway. So we got to do the same thing on San Jose. So go to San Jose. Where we at? I'm sorry, not San Jose. Miami. We're going to Miami. Okay, so exit. Oh, we're on the correct interface here. Interface FA0/1. And we're going to say IP OSPF message digest key 1. And then MD5, and then the key, which is San Jose. We're debugging here so we can see what happen over here. And then you got to do IP. Let's check Key West and see what happens though. Obviously they ain't got no neighbors yet. Do show IP OSPF neighbor. He has no neighbors, right? As you can see, no password was set up on Miami yet. So let's go ahead and do that. So IP OSPF. Oh, we did set up the password. What am I thinking? We just didn't set up message digest. So IP OSPF authentication. Authentication. Good thing we did it this way. We can see what happens. Let's see. He's debugging? No, he should be debugging those events. But anyways, IP OSPF Authentication Message Digest. And now we should at least become neighbors. And while that's happening, let's go ahead and take a look at our next tasks. We reconfigured Key West to use MD5. We configured Miami to use MD5. Briefly explained the MD5 hashing algorithm. So MD5 is basically you jumbling up a password so that way nobody else can see it. It's almost like encrypting. But remember, encrypting means it's like a two-way key. Hashing means it's just like kind of like one way and you jumbling it. And there we go. We went from loading to full. So now we're neighbors. So we run that command again. You can see he has a neighbor. Full. And that guy is the designated router. Beautiful. Let's go ahead and verify. Run some verifying commands. Verify routing tables. Oh boy, this is just some basic homework here. We'll stay on here and do show IP routes, and you can see he still has 8 OSPF neighbors. 8 OSPF routes. He wants us to basically verify connectivity. Or actually, after you have configured authentication, display the routing table. Any changes? No, there aren't. From host E, ping the following IP addresses. From host E, he wants you to ping all these other hosts. Basically, they work because I'm pretty sure it works. It did work. They wouldn't have set up for it this way. From host B, we're going to do host B, ping the FA00 interface, Key West's FA00 interface, which is there. I believe the local area network connection interface. So yeah, so he wants host B to ping that right there, which was 193. That's the same thing right there. Yeah, basically right there. So ping this guy, 0% loss, and we got full connectivity. Is this ping successful? Yes, it is. If not, review and correct your configuration. Based on the behavior you observed in the previous 2 steps, what conclusion can you draw regarding the operation of OSPF encrypted authentication between Key West and Miami? The behavior we observed is that once password is set up on one, the other one got to be set up too, because it'll drop neighbors if they are not the same, or if the same setup is not, if they're not set up the same. What else can we do to verify this information? Let's just do a show. Let's go to Miami, and let's just and there goes the debugging events that we were looking for. Let's just do a show IP OSPF. What command can we run here? Yeah, IP OSPF interface FA0/1. And there you go. Right there. There it goes. Message digest authentication is enabled. Youngest key ID is 1. And that's pretty much it. Let's check our work here. Lab results, and everything's good. We got all green check marks. So that was a basic setup for IP OSPF authentication. I hope you liked this video. If you do, please share this on your Twitter. Share this on your Instagram. Share this on whatever social media network you use. That is my contact information. That's my YouTube handle. That's my Twitter handle right there. Please comment. Please like. Please share. Please subscribe to the network.